I'm going to record this on the screen. So let's start a new. We're in dark mode. So this is going to be a very quick lesson on. Let's see if we can find the screen. New note. Linear transformations. Formations of given functions and their graphs. This is a very quick topic. I did mean to cover it last week during revision week, but we just didn't get around to it, and so this will be a quick 10 or 15 minute tutorial on how to do that with one example. Which is something we have done before, or we should have done before in the first term, or just after the Christmas holidays when I wasn't here. But just in case you've forgotten, I'll go over it now. So let's choose the graph paper. So let's use a light background as well, and let's choose graph paper so it looks like a maths. It'll help us to draw the lines. So linear transformations of given functions on the graph. Basically what happens here is they give you a graph of, this is quite a common exam type question. They give you a graph of an unknown function and they tell you to make some transformations on it and then sketch the new transformed graph. It's not too difficult, but as long as you follow the basic rules, it should be fine. So I'm doing this on my iPad because I find it easier than using the Windows tablet. Hopefully it should work. So let's choose a pen and let's start with black. Let's write with blue. Let me write a typical question. Given the graph of fx, sketch, and sketch means it just has to be a quick sketch with the salient points on there. Doesn't have to be a detailed drawing. Sketch the graph of gx is equal to, let's say, 1/2 f bracket x minus 1 plus 2. So the new graph we will have to sketch will be this. Let me highlight it. Let's choose the highlighter pen. So the new graph we have to sketch is this highlighted one, and let's see what the original graph they give us looks like. So let's let's use a ruler, draw a quick little graph of fx. So let's say here, and I'm just going to make up a simple shape, but generally the graphs they give you to draw at a cellular level are quite simple anyway. So let's go back, move the ruler out the way for now. Let's go back to our pencil, let's go back to black. So this is our x-axis, this is our y-axis, here's our origin. Let's say the original graph looks like this. Like that. So let's say that's points, call that point A, point B, point C, and let's do here point D. So let's put some coordinates on there. They will usually give you the coordinates, or they'll be very easy to work out from the scale. So here, let's say A is x is 0, y is 2, 4, 6, 8, 10. Let's say B is x is 2, y is 12, no, 14. And let's say C here, x is 5, y is 2, and D is x is 6, y is 4. This is just a rough sketch. So now the way we're going to transform it is, this is our new transformed function. We have some basic rules. So the first one to remember is, let me change the color. Let me go to the highlighter pen again here and choose green. If we have anything inside the bracket, so here we have x minus 1 inside the bracket. The rule for that is anything that's inside the brackets, the parentheses, that only affects the x-axis, x coordinate only. Let me choose the other pen, so this one. So this here will affect the x coordinate only. And conversely, things that are outside the bracket, so the half here and the +2 here, they will only affect the y coordinate only. Y only. That's basically it. The only other thing to remember is inside the bracket, so when we're dealing with the x coordinate, and x minus 1 represents a horizontal shift to the right by 1 unit, and therefore if the sign is a -1, it means we have to do the opposite. That means add 1 to the x coordinate, and if it was x plus 1, we would have to subtract 1 from the x coordinate, and then if it was x plus 1, it would represent a horizontal shift to the left by 1 unit. In this case, we have x minus 1, so this will represent a horizontal shift by 1 unit to the right. So in practice, this means for all our points A, B, C, and D, we will add 1 to the x coordinate when we're dealing with this particular part of the transformation. So on this function gx, we have half x minus 1 plus 2. So we have 3 transformations. We have the x minus 1, we have the multiplying scale factor of multiplication by half, and the +2. So the multiplication by half and the +2, they will only affect the y coordinates, and the x coordinates will not be affected by those 2 transformations. So let's change color again. Let's go back to black. Let's write down our coordinates. I'll do it over here just to save space. So let's restart with our A coordinate, A. That's not very nice. Let's do it again. We start with our A coordinate here. It is 0, 10. Now, if I'm going to do the inside the brackets first. So we have x minus 1. That, as I said, it means that the x coordinate gets added to 1 to the x coordinate. So 0 plus 1 is 1. The y coordinate is unaffected. So our new A coordinate is what we call A dash. That becomes 1, 10. Now the next thing we did was multiply by a half f, x minus 1 here. So this only affects the y coordinates because it's outside the brackets, outside the parentheses. So now we have 1 for the x, that stays the same as before. The y was originally 10, so if we multiply 10 by half, we get 5. So now we get 1, that maps to 1, 5, and we call that a double dash. And now the last thing we have to do is this one, the +2. So this will give us, if we +2 here, we will get a triple dash, and that will be, again, the x stays the same. We add a 2 to the 5, so 2 plus 5 is 7. So our final coordinate in the A will be 1, 7. I'm going to highlight that just so you remember. I'll highlight it green. So our final A coordinate will be 1, 7. Now we're going to do the same, exactly the same for the other three coordinates. So B, I'll do it underneath the graph in case it doesn't rub onto the graph. So B, chose the wrong pen. B was 214. So after the first transformation of fx minus 1, remember we just add 1 to the, so that's b prime or b dash, we add 1 to the 2, so 2 plus 1 is 3. The y coordinate stays the same, and the rest of the transformations only affect the y coordinates because they're outside the bracket. So half fx minus 1 plus 2, the half of fx minus 1, so the only affects the y, so the 3x stays the same as 3, and half of 14 is 7, so we get 3, 7, and then finally the last transformation was plus 2. So if we add the plus 2 to the y, we get 3, 9, and this is going to be our, that's going to be, so this was b dash, this here is b double dash, and this is b triple dash. So let's just highlight that again, just to make it easier for you to remember. Let's do that in green again. So we choose our highlighter pen, green. So here, whoops, that's not green. Highlighter pen, green. There. So our B coordinate will end up, start with 214, end up on 3, 9. Now we're going to do exactly the same for C. So C, we don't want it green, we want it black. So C, I initially started off with 5, 2. So after the transformations, I'm not going to go through them. Again, C dash, we just fx minus 1, so we can add 1 to the x coordinate, becomes 6, the y stays the same, then the half fx minus 1, so the x stays the same, and the y half of 2 is 1, and then finally we add 2, so the x stays the same as 6, and 1 plus 2 is 3, so C triple dash becomes, we highlight it again, C triple dash, there's the highlighter pen, choose green, C triple dash is 6, 3, and we're going to finally do the same for point D. Let's go back, choose the right pen, this one, choose black. So point D was 6, 4. So the first transformation we did is f bracket x minus 1, so horizontal translation by 1 unit to the right. That gives us d dash of 6 plus 1 is 7. So 7, the y stays the same. 7, 4. Now we're going to do the half fx minus 1, so the scale factor of a half, because it's outside the brackets, only affects the y coordinate. So d double dash will be, the x stays the same as 7, y was 4, half of 4 is 2, and finally we have d triple dash, so that was plus 2, so the x stays the same as 7, and the y, 2 plus 2 is 4. So our final coordinate is, we highlight it, 7, 4. So what we're going to do now is on our original sketch here, we're going to add, usually on the questions you have to sketch it either on the same graph or on they give you space for another graph, but it doesn't matter which way. The process is the same. So let's go, let me choose red. Let me choose this pencil, let me choose red to do the actual transformed function, which is gx is half fx minus 1 plus 2. So the first thing to do is our 4 transformed coordinates a triple dash, b triple dash, c triple dash, d triple dash. I'm going to put them on our axes. So a triple dash is 1, 7, so I'll do these in red. So x is 1, y was 7, so 2, 4, 6, 7 would be here roughly, so 1, 7 would be about there. So this is going to be a triple dash. B will be 3, 9, so 3 here, 9 here roughly. So it's only a sketch, so it doesn't have to be exact, it has to be close enough so that the examiner understands, you understand what you're doing. 3, 9. C is 6, 3, so 6 here, 2, 4, 3 is here, so that'll be C dash, 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 6, 3. Let's write in B as well. B was 3, 9. Notice if you be systematic and you write everything down, then there's much less chance that you make a silly calculation mistake. A triple dash was 1, 7. So we have 1, 7, 3, 9, 6, 3, and D 6, 4. So D triple dash was 7, 4. Let's double check. 6, 4, 7, 4, half of that would become 7, 2, add the 2, 7, 4. So here's 6, here's 7, 2, 4, 7, 4 would be here, D triple dash, 7, 4. Now we've got our 4 red dots, but remember the rule is with transformations, the basic shape stays the same, just the location and the size can change. So we have this basic shape. So I'm gonna, because I did the points in red, I'm gonna do the actual shape in blue. So it looks roughly like this. There, way to C, then up to D. So here in blue is our transformed function. I'll write here gx equals 1/2 of fx minus 1 plus 2, and our original function, which usually is given, is the one in black, that was fx. Now that's really it. The only other thing that you can sometimes be asked is to write down a description of the transformation in words. So here I'll write the 3 things down. So the first one, x minus 1, was, let's do it in different colors. So we'll do the, what color did I use above? So in green, we have a horizontal, so this bit here is a horizontal translation. Remember, if you're moving left or right, it's called a translation, horizontal translation by 1 unit to the right. Let's choose red for the half on the outside here. So this half is a scale factor 0.0. scale factor multiplication of 1/2, and +2, let's do that in, what other colors do we have here? Let's do that in yellow. So this +2 here in yellow, that is because it's moving 2 up in the y direction. That's a vertical translation by 2 units. Upwards. Or you can also say by +2 units. If it was going down, it would be by -2 units. So this is called a description. So that's really it. This topic could come up. It's generally quite a common topic they ask on the IB exam. So I hope this has been useful. I will now upload this to your classroom, and if you have any questions, send me an email. Thank you for watching. Please leave any comments on Google Classroom as well.